I will provide solutions of a few questions, except those I have already covered in the classroom teaching. Here is the 38th question. Let Px comma y be any point in the first octant. All are positive. Okay. All right. Now the foot of perpendicular, the projection. Projection is nothing but foot of perpendicular. In xy plane, BQ. So what is the foot of perpendicular? Foot of perpendicular is Q. So this lies in xy plane. So we take xy0. If we assume that this is x-axis, this is y-axis, this is z-axis. Well, okay. Now what is happening? What is the next one? OP equal to gamma. So OP equal to gamma. This length is gamma. The angle between OQ and the positive x-axis, the angle between OQ and the positive x-axis is given as alpha, right? Sorry, theta. This angle is theta. All right. And angle between OP and positive z-axis, OP and positive z-axis is phi. This angle is phi. Y is origin, asking the distance of P from x-axis. The distance of P from x-axis, that is PM. So the distance of P from x-axis is nothing but root over y square plus z square. This we want. Now, given that angle between OQ bar vector and x-axis, that is I cap, that's equal to theta, implies what is cos theta. So cos theta is equal to x by under root x square plus y square. All right. So this is nothing but x by under root gamma square minus z square. Because gamma square is equal to distance of the point x square plus y square plus z square. Got it? All right. So what is cos square theta? It is nothing but x square by gamma square minus z square. Okay, this is equation 1. Now angle between OP bar vector and k cap is given as phi. So this implies that cos phi equal to you will get z by under root x square plus y square plus z square. Nothing but gamma. So this is nothing but z by gamma. So from this, what is z? Z is equal to gamma into cos phi, isn't it? Well, here you see this PM is nothing but this is gamma square minus x square. So substitute this z value, put in 1. Z value put in 1. Then we'll get that cos square theta equal to x square by gamma square minus gamma square cos square alpha. Cos square phi implies this is gamma square into cos square theta into sin square phi. After taking gamma square common, we are getting x square. Substitute here. So therefore, that PM is equal to under root, okay, gamma square minus x square, nothing but gamma square into cos square theta into sin square cos square phi into sin square theta. Sorry, cos square phi, sin square phi into right, sin square phi into cos square theta. This is the answer. Next question. X, Y, Z coordinates of each vertex of a triangle are in AP. Right? And X and Y coordinates of a centroid are 1 and 3. Assume vertex A equal to 1, 2, 3. You take your own numbers which are in AP. B is equal to 2, 3, 4. C you should not take directly. We have to take as ABC. Right. So centroid of x coordinate, this is gx, centroid of x coordinate is given 1. That is nothing but 1 plus 2 plus a by 3 equal to 1 implies a equal to 0. Centroid of y coordinate is equal to 3. Nothing but 2 plus 3 plus b by 3 is equal to 3 implies b value equal to 4. Since ABC are in AP, since ABC belongs to AP, okay, therefore C value must be 8. C value must be 8. So what is the centroid of Z coordinate of centroid? This is equal to 3 plus 4 plus 8 by 3, nothing but 5. Hence, the centroid coordinates are G is equal to 1, 3, 5. Asking what is the distance of the centroid from origin, that is root 35. Next question. 3 lines are given L1, L2, L3, for which the points Q on L2. So Q you can take that directly on L2. You can take that, okay. This is 0. There is no I component. J component is mu and K component is 1. This is the any point on line 2. We can find a point P on L1. This belongs to L2. We can find a point P on L1. So what is any point on L1? On L1 is nothing but lambda 0, 0. There is no J and K component in line 1. There is no J and K component in line 1. This belongs to L1. And a point R on L3. Point R on L3, that is 1, 1 and nu. This belongs to L3. So that PQR are collinear. PQR are collinear. Nice. So we know that their collinear is nothing but PQ bar is parallel to PR bar. Isn't it? Well, so PQ bar is nothing but OQ minus OP, that is minus lambda, by PR bar is nothing but OR minus OP, 1 minus lambda, equal to mu minus 0 by 1 minus 0, equal to 1 minus 0. This is nu. All right. We got it. So we have to find out a point P. Remember, we have to find out. We can find a point P and L2 and a point on L2 are collinear. Okay. For which points Q on L2 we can find. So you are asking to find the point Q on L2. They are asking. right? For which points on L2? They are asking on L2. So nothing but mu coordinates. What can be the mu values? Well, see, anyway, there is no I component. There is no I components. So therefore, either J and K components combinations you will get. All right. This implies, of course, there exist infinite vectors. Infinite vectors. So here, anyway, this K is constant. That is K cap. Only mu is changing. First option, for option A, mu is equal to minus half. Mu is equal to minus half. Then you will get that lambda by lambda minus 1 is equal to minus 1 by 2 is equal to 1 by gamma. So we got that gamma is equal to minus 2. And this is 2 lambda. 2 lambda is equal to minus lambda plus 1. So implies lambda is equal to 1 by 3. So there exist points P and R on L1 and L3. So this option is true. Well, in the similar fashion, we can identify the remaining. What about option B? Option B is mu is equal to 0. When mu 0, gamma doesn't exist. 1 by gamma is equal to 0. Not possible. Not possible. Option C, when mu is equal to 1, then you will get gamma equal to 1 and this lambda by lambda minus 1 is equal to 1 implies lambda equal to lambda minus 1 not possible. So this is also not possible. Finally, option D, that mu is equal to half. I think this is possible that gamma is equal to 1 by 2 and lambda is equal to, you can write 2 lambda is equal to lambda minus 1 implies lambda is equal to minus 1 possible. So option A and D are possible. Let L1 and L2 denote the lines respectively. If L3 is a line which is perpendicular to both L1 and L2, okay? Right. So L3 is perpendicular to L1 and L2. Well, assume that first line is parallel to D1 bar vector, second line is parallel to D2 bar vector. Now L3 is perpendicular to D1 bar and D2 bar. Implies L3 is parallel to D1 bar cross D2 bar. So what are the DRS of L3? Right? So what is D1 bar cross D2 bar? That's equal to determinant of I, J, K minus 1, 2, 2, 2 minus 1, 2. This is equal to 4 plus 2, 6i minus 2 minus 4 plus 6j and this is 1 minus 4 minus 3k. All right. Okay. Okay. So here if the L3 line is which is perpendicular to both L1 and L2 and cuts both of them, then which of the following options describes L3? So L3 is the shortest distance line. L3 is the SD line, which is perpendicular to both L1 and L2 and it cuts both of them. So now any point on L1, implies you can write P equal to what is I component 1 minus lambda and J component 2 lambda and K component 2 lambda. What is any point on L2? Q is equal to I component is 2 mu minus mu and 2 mu. Right. Now PQ is parallel to D1 bar cross D2 bar. D1 bar cross D2 bar. Well, okay. So now it is so simple that two vectors are collinear. Collinearity of vectors is so important, right? These are the skew lines L1 and L2. And a line L cuts both of them perpendicularly. This is nothing but SD line, PQ. We want that. So this implies that 2 mu minus 1 plus lambda by 6 is equal to minus mu minus 2 lambda by 6 is equal to 2 mu minus 2 lambda by, okay, what is that? Minus 3. So it is just we need to find out lambda and mu, so that you will get the points. What are the DRS? This is parallel to the vector 2i plus 2j minus k. This vector is parallel to. Well, so this implies here you see that 6 cancel, then you will get 3 mu plus 3 lambda minus 1 is equal to 0. And here you see that this is mu plus 2 lambda is equal to 4 mu minus 4 lambda. So this implies that 5 mu is equal to, sorry, not 5, 6 lambda. This is 3 mu. 3 mu is equal to 6 lambda. So mu is equal to 2 lambda. Well, so this implies 9 mu, 9 lambda. 9 lambda is equal to 1 implies lambda is equal to 1 by 9. Mu is equal to 2 by 9. We got the answer. So what are the points P and Q? So therefore P coordinates are 1 minus lambda nothing but 8 by 9 and 2 lambda is nothing but 4 by 9, 2 by 9 and next 2 by 9. So SD line, okay, SD line that is L3, SD line L3. R bar is equal to, it passes through the point that I can take 2 by 9 common. I will get 4i plus j plus k plus some t into 2i plus 2j minus k parallel to this vector. So option B is true. Similarly, option C is true because Q point is equal to, you will get, substitute that 2 mu, that's equal to 2 by 9. Mu is equal to 2 by 9. So 4 by 9, that's equal to minus 2 by 9 and 4 by 9. You see that. Okay. Wait, not option C. I think option A is true. All right. Next, moving to the next question. Line passing through the origin perpendicular to both the lines. Perpendicular to both the lines, right? A line L. Sorry, this is a line L. I don't know whether you will ask a line L. Right. So L is perpendicular to L1 and L2. Now same procedure, right? So DRS of L, that is cross product of directional ratios vectors, that is 1, 2, 2. Next, 2, 2, 1. This is equal to 2 minus 4 minus 2i 1 minus 3 plus 3j, 2 minus 4 minus 2k. So what is the line L? Line L is given by it passes through origin. So x minus 0 by minus 2, y minus 0 by 3, z minus 0 by minus 2. Well done. The points, the coordinates of the points on L2, the coordinates of the points on L2 at a distance of root 17 from the point of intersection of L and L1. So we need to find out point of intersection of L and L1. You assume that this is equal to some P, right? Any point on L, any point on L. That is minus 2P, 3P, minus 2P. We want to find out point of intersection of L and L1. Any point on L, any point on L1. Already it is given 3 plus T minus 1 plus 2T, 4 plus 2T. Now we have to equate them. 3 plus T is equal to minus 2P. Z coordinate, I'll equate that 4 plus 2T is equal to minus 2P. Just subtract them. Just subtract them. You will get minus 1 minus T equal to 0. So T is equal to minus 1. Therefore, point of intersection of L and L1. L and L1 is equal to that point is 2 minus 3 and 2. Assume this point is P. Now find the coordinates on L2 at a distance of root 17 from point of intersection. Right. Okay. So any point on L2, any point on L2 that is already there, Q 3 plus 2s, 3 plus 2s, 2 plus s. This is any point on this. So now given that PQ square is equal to 17. All right. So you will get that 2s plus 1 whole square and 2s plus 6 whole square and s square is equal to 17. This implies 4s square plus s square, nothing but 9s square. 4s plus 24s. Okay, this is 9s square. All right. This is 9s square. This is 4s. This is 24s. So 28s. 36 plus 1, 37. So you will get plus 20 is equal to 0. So 20 into 9 is nothing but 180. Or I can write 10 into 18. This sum is right. This is correct. So we got that this is 9s square plus 18s plus 10s plus 20 equal to 0 implies if you take 9s common, you will get s plus 2 plus 10 common, you will get s plus 2 equal to 0. Either s is equal to minus 10 by 9 or minus 2. So we are asking what are the points on L2. So substitute here Q coordinates. Q coordinates, if you substitute -2, you will get -1, comma 0. And if you substitute -10/9, you will get 3 minus 20/9, 3 minus 20/9, 2 minus 10/9. We got it. Okay. 49 is similar to above questions only. A line L passes through the origin and perpendicular to the lines. Perpendicular to the lines. So what are the DRS of L? DRS of L, that cross product of directional ratios of L1 and L2, I, J, K, 1, 2, 3, 2, 2, 1. This is equal to 2 minus 6, that is minus 4i, 1 minus 6 plus 5j, and 2 minus 4 minus 2k. These are the DRS. So what is the line L? Now line L is passing through origin having DRS minus 4, y minus 0/5, z minus 0/-2. Line passes through origin having DRS -4, 5, -2, perpendicular to both L1 and L2. If P is the point of intersection of L and L1, if P is the point of intersection of L and L1, L and L1, okay, any point on L, okay, -4t, this is, you say, this is t, -4t, 5t, -2t. Any point on L1, okay, this is, you can say R. Any point on L1, nothing but 1 plus lambda, -11 plus 2 lambda, -7 plus 3 lambda. I hope you can do. Now equating these two. So this implies that -4t is equal to 1 plus lambda, -2t is equal to -7 plus 3 lambda. Multiply this equation by 2 and then subtract. Okay, etc. You find foot of perpendicular. Next question. Oh, oh. 51 question printed wrongly, respectively at point P and Q. Something like 51 question printed wrongly. Let the coordinates of one vertex of triangle ABC be A0 to alpha and other two vertices lie on this line. For alpha belongs to Z, if the area of triangle ABC is 21 square units, then the line segment BC and the line segment BC has 2 root 21. Then alpha square is equal to. Well, it is just we need to find out that what you can say length of the perpendicular distance from a point. Okay. All right. This is the line. A 0 to alpha. And these are the B and C points. So BC length has given that 2 root 21. Right. Now what we need to find out height of the triangle. height of this triangle. All right. And line passes through the point, minus alpha 1 minus 4. This is the line passes through the point P. Okay. All right. Area of triangle is 21 square units. So delta is equal to 21 square units. Half into, this is the height h, into base is 2 root 21. Implies that h square is equal to 21. So we need to find out the height of this triangle. Okay. I'll join this. Assume this angle is theta. Okay. What is this vector? This vector is minus alpha I minus j and plus, sorry, or you can say minus of 4 plus alpha j. Okay. And the line is parallel to the vector 5, 2, 3. So here I can write that cos theta is equal to AP bar vector dot 5y plus 2j plus 3k, DRS of the line, whole by modulus of AP bar vector modulus of 5y plus 2j plus 3k. Well, so this implies that cos theta is equal to, okay, so what is AP bar vector? This is AP bar vector. I can write minus 5 alpha minus 2 and minus 3 into 4 plus alpha, whole by under root that root over alpha square plus 1 plus, or else you can find the foot of perpendicular from a point, into root over 25 plus 9 plus 4, 38. This is root over 38. Better I'll skip this idea. I'm dropping this idea. Instead of this, I will find out that foot of perpendicular from a point on the line. Assume this point is Q. Okay. Q coordinates, any point on that line is 5t minus alpha, 2t plus 1, 3t minus 4. So here AQ is perpendicular to the line L. Therefore, 5t minus alpha into 5 plus 2t minus 1 into 2 plus 3t minus 4 minus alpha into 3 equal to 0. So that we have to find out t in terms of alpha. So 25t minus 5 alpha plus 4t minus 2 plus 9t minus 12 minus 3 alpha equal to 0. All right, this is 13 plus 25, 38t is equal to, this is 8 alpha, sending that side, 8 alpha, and this is minus plus 14. So we got that t is equal to 4 alpha plus 7 by 19. Or no? Okay. So here given that PQ square is equal to 7, AQ square is 17. AQ square is 17. AQ square is equal to 21. So what is that? AQ square is equal to 21 is nothing but 5t minus alpha whole square plus 2t minus 1 whole square plus 3t minus 4 minus alpha whole square given as 21. All right. Okay. All right. This is substituting that t here. I will check once whether it is correct or not. Well, here it is given that alpha is an integer. Alpha is an integer. Okay. So we need to find out t. Here you see that alpha is equal to 19t minus 7 by 4. It must be an integer. All right. So implies t equal to 1. Therefore, you will get that alpha is equal to 12 by 4, that is 3. That's it. That answer is over or not. That we don't know because that we have to get that h square. So what is the point q now? In that case, that point q is equal to, you will get point q. So here the point A is equal to 0, 0, 2 alpha, 0, 2, 3. And what are the coordinates of q? Coordinates of q are nothing but 5t minus alpha. Okay, 5t minus alpha. All right, 5t minus alpha. So 5 minus 3, that is equal to 2. 2t plus 1, 3. 3t minus 4 minus 1. So what is AQ square length? 4 plus 1 plus 16. That's equal to 21. Now it is true. Of course, there are many values of t for which t is integer, but exceptionally we want that h square is equal to 21. This is very good question. I'll check if there is any else question. Okay. I will solve that 54th question last. Consider a line L passing through the point. So therefore line L is x minus 1 by 2 minus 1, 1, y minus 2 by 3 minus 2, 1, z minus 3 by it is 2. The distance of the point 11 by 3, 11 by 3 from L along this line. So which means that this is the given line. Okay, this is L. And assume that this is the point P. This is the point P. And assume that the given line is like this. Given line, suppose assume like this. This is the line 1. Okay. You rewrite the line 1 x minus 11 by 3. Okay. By 2 is equal to y minus 11 by 3. Okay. No problem at all. Z minus 19 by 3 whole by 2. So what are the DRS of this line? We want only DRS 2, 1, 2. So we have to measure the distance like this, parallel to this. Right. Assume this point is Q. So what are the DRS of this line? This is parallel to given line. So 2, 1, 2. So therefore, we want to write this equation of line assume L2. So what is equation of L2 line? L2 line is nothing but x minus 11 by 3 by DRS same as of L1 to y minus 11 by 3 by 1 z minus 19 by 3 by 2. Assume this is equal to some t, right? So therefore, what are the q coordinates? Q coordinates belongs to L2 implies I can write q is equal to 2t plus 11 by 3 and t plus 11 by 3 and t plus 19 by 3. It also lies on line 1, sorry. It also lies on line L. So therefore, this is the line L. This is the line L. Substitute these coordinates on that line L. X minus 1, x minus 1. So 2t plus 11 by 3 minus 1 is equal to y minus 2. So t plus 11 by 3 minus 2. Right? I think this is enough to find out the value of t. So this implies t is equal to, you will get minus 1. Okay. So therefore, what are the coordinates of q? Coordinates of q are now that t is minus 1. So you will get 5 by 3. This is 8 by 3. This is 16 by 3. Now find the distance between P and Q. Enough?